Look at the 3 dimensions here again. I will say one more time. Can you see? You got right here. So when I have 1 dimension, you're talking about a line. When I measure a line like this, you just have one measurement. That's called 1 dimension. So one measurement would be, let's say, cm. If it's unit, it's unit. In cm, it's cm. If it's 1 unit, it's 1 unit. In cm, it's cm. In meter, it's meter, or kilometer also. Just one line. Okay? One measurement. Now, when I make it become 2 dimensions, like a flat shape, in this case, a square here, it now has 2 dimensions. What are the 2 dimensions? So we call 1D, 1 dimension, 1 length. So now a 2 dimension shape has 2 dimensions, 2 measurements. It will be length times breadth. For example, the space that is inside. You are looking at the space that is inside. And to calculate that, for most of the shapes, you use length times breadth, squares and rectangles. But for triangles, we just learned that it's different. For triangles, it's half times base times height. But in any case, you will always have a 2 measurement multiplied together. Cm times cm, unit times unit, meter times meter, kilometer times meter. 2 dimension, 2 measurement, this is called area. Now, so I'll end up having cm square, unit square, and meter square. We call square centimeters, square meters, square units. Now, when I expand this figure, this dimension, I make this dimension into a 3-dimension object. Now, in this 3-dimension object, I'm able to have 3 different kinds of measurements. This 3D possible, I will have 3 dimensions, called volume. When I fill in a 3-dimensional space, you can have up to 3 different kinds of measurements. In rectangular tanks, cuboids and cubes, there are 3 dimensions, 3 measurements. For example, length times breadth times height. When you multiply these 3 types of measurements together, how long, how wide, how tall, I get, say, centimeter times centimeter times centimeter, units times unit times unit, meters times meters times meters. Can you see I'm putting 3 different measurements together? That's why I call 3D. And that's why my volume unit becomes cubic centimeter, cubic unit, or cubic meter. It's a little 3 on top. Because I multiply 3 related measurements. Can you understand? Now I will stop here and ask someone to take note of this. Okay, time for some example. Can you see? Okay. Right. Now the question is, can you see where I have 2 dimensions here in this 3 dimension? Where can I find this? Oh, are you all familiar with this? That doesn't look very well. So that is too strong. But it's not so much about the throwing. Can you see what happens to the set of parts? Can you see what happens to the parts here? Now, if I look at one part, if I look at just one part, what do you notice about the one part? It's just one part. Can you see if I call this 2D, where's the 2D? It's like this. So I can say this is 2D, right? How is this 2D? Here, how long and how wide, right? Correct? So in a cuboid, can you notice where it is? Where? If it's a cuboid or a rectangular tank, can you notice where it is? Let's say I take this box out. This is a cuboid. Can you see where's the 2D? Where's the 2D? It can be the front side here. Where else can be the top view? The side view? Or if I just want to talk about how long and how wide, where would it be? Either the top or the bottom. Very good. So it's either the top or the bottom. So I will call this 2 dimension. What is this 2 dimension again? Area. So imagine I have a tank now. This is a tank, which I will bring a tank tomorrow. Okay? So tomorrow I'll bring a tank. Imagine this is the bottom of the tank. I call it area. Right? But I start to fill the tank up layer by layer. Layer by layer. Oops. Layer by layer. Layer by layer. Put more layers onto it. What do you see? It gets thicker and thicker and thicker. The stack of parts goes taller and taller and taller. The height increases. Can you see? Where's the height now? At the side here, right? Can you see I grow the dimensions by stacking it? So where's the, can you show me, tell me, looking at these 3 dimensions, you have a cube in front of you, right? Most of you have the cubes in front. Can you show me where is 1D for you? Where is 1D on the cube for you? The outline. Which outline? Give me one clue. What do you call it? How do you know which part? What is the 1D? It's one straight line. So why is that one straight line called? CM. So what is it called? Length. So can I say the breadth is also one dimension? If you look at your cube now, can you find where's the breadth? In my stack of cards, can you find where's the breadth? Where's the length? Just here, right? Only this line, right? Only this edge of the cups. Can you see? Only this edge. Where's the breadth? Only this. Only this short side of the 2D, either the top or the bottom, right? Now, where can I find the dimension that says height? Here, right? How much I stack these parts up, right? Can I? This is still one line, right? One line here, one line here, one line here. CM, let's say CM. CM times CM times CM. How long, how wide, how deep? Times together, I get CM times CM times CM, I get cubic centimeter. Can you understand? Now, if you look at your book now, here, I would like you to use 3 colors to highlight the length, breadth, and height, and measure and label it length, breadth, height. Thank you.
Really? Wait a bit.
Okay. Audi did it in his book, even though he didn't use a highlighter as I wish that he did, but he did it in a manner that still helped him to see the length, breadth, and height. So this is page 927, right? Right. The cuboid measures here. You can use color pencil also. Some of these color pencil. Okay, thank you. Thank you, Akil. Very great assistant. Alamak. I just step on my own foot. I'm okay. Okay. Now, so I'm looking at this cuboid here. Thank you. I'm going to color 3 colors. So careful. Okay. So I measure one side. How long? Label it. Thank you. This is length. This measurement was 1 meter. You see the meter is just meter, 12 meters. Okay. Then I have the breadth. How wide is this cuboid? It's 8 meters. This is the breadth. Then you have the last one. How deep is this cuboid? How tall is this cuboid? So I have 3 colors: length, breadth, height. 4 meters. How long? How wide? How tall? Can you understand? Now, in this case, I can see the 3 measurements: meter by meter by meter, meter by meter by meter. If you look carefully, how is the measurement happening? It's happening with volume is now meter times meter times meter. That's why I have this cubic meter. Can you understand? Can you understand? This is in your textbook, page 127. So you find the volume of the cuboid by multiplying these 3 dimensions, these 3 measurements together. Each dimension is just one dimension, meter. When I multiply, let's say, if I say 12 times 8, 12 times 8, what is 12 times 8? What is 12 times 8? Why is this 12 times 8? Why is this 96? Is it the whole thing? Whole of what? Whole of the cuboid? So what is 12 times 8? 12 times 8 is 96. What is 96 then? Is the length times the breadth. So what is length times breadth? What is length times breadth? Is 96. 96 what? Square meters, meter square. Can you tell me what is this supposed to mean? So I have this stack of cards here. I have the length, breadth, and height. If I multiply just the length and breadth, what measurement is this? The area. Thank you very much. Area of what? Area of the 2D part. What is this 2D part? The rectangle. That means either the top area. So this one, if I multiply, this gets me area. Do you understand? I get this top only. This rectangular space here is area. The top area or the bottom area. Can you understand? You call it the base area. You ask the cuboid to sit on the table or the top area, that rectangular base area. When I multiply these 4 times, 4 meters, not 4 times. I multiply with 4 meters, that means I stack up. One rectangle, I stack up another one on top of it. 96 plus 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 96. How many times? I plus until how thick it is. Can you understand saying? I plus until how thick this is. That's where I get my volume. Understand? What happens if I chop this set of parts like this? What happens to the thickness? If I cut the cuts, the thickness becomes smaller. That means the height is shorter. Okay. That happens when I have a tank, and the tank I don't fill until it's full. Understand what I'm saying? So the height can be different. How deep is the pool is different when it's not full. Can you understand this one? This is very important. Huh? Now we throw on to your, I'll tell you your homework first. No, I don't tell you homework first. I'll tell you what I want you to do now first. Right now, I want you to take out your worksheet and go to the page that has the same thing as what you see here, which is page 146 and 147. I told you this is your homework, right? On Thursday. Very good. Now, on Thursday, page 147. Now, this part of the homework is something special. For every of these solids, I want to see length, breadth, height, length, breadth, height, length, breadth, height. I want to see the length. I never do homework. Sorry, I paused. Here, the homework that I want you to do, part of it we do it now. For this page here, I want to see you clearly labeling for every question, length, breadth, height, length, breadth, height, length, breadth, height. When I'm going to teach you area of triangle portions of it, because I think many of you struggle with area of triangle because you cannot identify base of the triangle, height of the triangle. So this is the part that you are going to practice really hard. At least get the basics right. If not, you can't do anything that can't cope with anything that is other than that. So right now, I want to see you label for every single one. Let's say I choose this yellow to be length. Yellow is length. Green is breadth. How long? How long? How wide? And blue is height. How tall or how deep? So I want to see you put and label clearly and where your eyes see the 3 dimensions. For example, here, how long, how wide, how tall. Can see? You look, if you can see, I find the 3 dimensions. You notice that every dimension now, can you see what I'm asking you to do? Those of you who have answered, do your homework, you answer all the questions. Good. Happy for you. I'm looking at right in front of me, not done, and do a sort of. Please start with thinking and knowing that, hey, this is something you can do. Planning the time to do it. Can you plan the time to do it? You will notice I colored yellow for length. I will label length. Blue for height, how tall. And 3, the green for breadth, how wide. So I continue the color. Length, breadth, height. Length, breadth, height. Oh, sorry, this is 3. Length, breadth, height. Have you done this? Have you done this? That is straight. Length, breadth, height. Length, breadth, height. Length, breadth, height. Is it okay? Label all of these as well as space 1 for it. Never mind about can you color? Highlight length, breadth, height, length, breadth, height, length, breadth, height. I want to see the coloring. As well as for your textbook, this page as well. So I color this page for you already. Why are you standing? Do you understand? I want to see you marking up length, breadth, height, length, breadth, height, length, breadth, height. Can you understand? Okay. Tomorrow I want to see this done. This must be done before we can move on. Is it clear? Okay. Tomorrow, just a reminder and body. I'm going to collect the first set for our volume already. You make sure you've already completed all the way to the faces. Is it clear? Good. Okay.